All right. Hi, everyone. Welcome to another installment of Legends of LambdaConf. This time around, we're very excited to welcome Harry Kimpel, who will be talking about AI monitoring. So, without any further ado, Harry, please take it away.
Awesome. Thank you very much for having me. I'm very humbled to be part of the series Legend of LambdaConf. The talk is around AI monitoring, and I'll show you, a couple aspects which are really important when it comes to these kind of topics nowadays. But first of all, I have to bring this up. Please don't make any buying decisions based on what you see in this webinar. This is the regular safe harbor slide that you probably all know. So who am I? My name is Harry Kimpel. I'm a principal developer relations engineer at New Relic. New Relic is kind of like a observability company, a full stack observability platform that allows you to monitor all different kinds of things from all the way from infrastructure to applications and services and real users monitoring all together. I am, based in this beautiful part of the world, which is in southern Germany, Bavaria, close to where the Alps actually begin. So what do I have covered or brought you for this session today? So I, put this on the agenda here. We'll first talk about, what are the different AI products that New Relic brings to the table, just to make sure that I set the scene on what we're actually talking about today. I have a couple of market trends and kind of like the opportunity for customers to engage in this kind of observability topic, and then we'll dive into the New Relic AI monitoring, what it is we'll cover, and what actually the result and the outcome is of this incredible feature. I have a couple demos to actually demonstrate what it is, and I think a demonstration shows the capabilities in much more detail and brings you some nice interaction. And I think I like being showing hands-on information, because I think it is much more interesting also for the tech people on this session. So we have a small simple Python app just to set the scene. I'll dive then into a more advanced use case. We'll cover this in a second, and then looking at different models and why this is important at the end of the session. If you have any questions throughout the session, please put them into the chat. I'll try to monitor the chat as well, but please, if you can, just put them into the chat, and we can, maybe cover them at the end of the session. All right. So without further ado, what is it that we're actually talking about? So when we talk about AI at New Relic, there's typically two things that cover this aspect. The one is here on the right-hand side, which is kind of like the consumer aspect of a artificial intelligence and LLM application, which basically enhances the New Relic capabilities. This used to be called Grok, but for some reason, we cannot use this name anymore, or don't want to use it anymore, because someone also named his product this way. So it's basically a capability that allows you to work with New Relic, ask any questions in real natural language, and then you can gather, for example, some information on, hey, New Relic, can you tell me how are all my services doing? Is everything okay? And if not, do I have any anomalies, any anomaly behavior somewhere? And this can also be extended into the alerting side of things. I can get alerts in real natural language, not focusing on very detailed technical topics. And all the different aspects of the platform can be managed using this capability, New Relic AI, or also referred to as Ask AI in the product. So this is an in-product experience in the New Relic platform. This is not what I'll cover today. What I actually am talking about today is kind of like the enabling side of the New Relic AI monitoring perspective. So this is when you as a company or you as a developer build your own AI LLM chatbots that interact with an OpenAI platform, or some other services like AWS Bedrock or LangChain or some other things, where you want to understand the performance and the interaction of all your applications with when talking to these LLM applications and the AI stack. We'll also cover, and this is a really nice aspect of it as well, the cost of running these LLM applications. There's also interesting aspects of, security and privacy because, as you may know, a lot of people are really a little bit scared about when using LLM or AI applications like ChatGPT. Companies as well, right? Because they are a little bit afraid that, some, information could be lost and, shared in these chatbots, which could then be reused to maybe train other models. So there's a lot of aspects that we really should focus about when talking about this. The quality side of things, quality of LLM responses, you may be familiar with, there's a lot of bias and hallucinations when it comes to AI applications. And you want to make sure that the quality of the responses are really to the level that you expect when running these applications. And then, of course, some generic insights into these applications. This could be metrics and events or logs and traces across the entire life cycle of your LLM application when it comes to prompting and responses from your chatbot. So this is the aspect that I'll cover in this specific webinar. When it comes to AI monitoring, we also think a lot about, what are actually the some market trends that are out there in the industry. And there's some really nice and interesting aspects that we can look at. For example, 70% of all the organizations that are currently exploring, running generative AI applications in their companies, in their organizations, which is a big number out there. 40% of enterprise applications, they will have a conversational AI embedded by the end of 2024, which is also, a huge aspect and a really important topic. And also for consumers, 75% of consumers are really concerned about the misinformation from AI. I put some links for each of these stats into the slide deck, which I'm happy to share after the talk. But these are really interesting numbers, and the reason why we actually came up with a AI monitoring capability and feature, which hopefully helps you to target each of these trends and maybe also alleviate some of the challenges. Talking about challenges, what are those challenges that we typically see when running these AI applications? First of all, it has an increased complexity. AI applications come with additional components like LLMs, large language models, vector data stores, orchestration frameworks, and so on. And this added complexity makes troubleshooting and performance optimization a whole new ballgame. So it's really something where you need to be really, deep into the weeds of your application to find out what is actually happening. So the increased complexity is really one of the key challenges when it comes to AI monitoring. Then secondly, it's a new telemetry that you need to monitor. Unlike your usual apps, AI throws basically two curveballs when it comes to monitoring quality and cost to it. From the quality perspective, you need to make sure that your AI is putting out accurate, reliable results, free from bias and offensive content, and just plain made up stuff like hallucinations. So you want to make sure that the quality is really what you expect from your applications. And this isn't just about the user experience, it's also about using AI responsibly and ethically. So this is another big challenge that we see when talking about with customers. The costing aspect, so counting the tokens and controlling your bills is another big aspect. So each time your AI analyzes a word or generates a sentence, a response, or translates something, it uses so-called tokens, which basically translate to money spent at the end of the day when it comes to your platform, your AI platform of choice that you're using. And monitoring the token usage lets you keep an eye on on your AI running costs and avoid unexpected bills. So really another big aspect that you want to make sure. And also when it comes to the telemetry, the AI platforms, they are also constantly evolving. So they are putting out new models, increased, more optimized models of the same, underlying model. So they also evolving constantly. And you want to make sure that you are constantly knowing what is actually going on. If there's a new model or sub-model, for example, from OpenAI that we are using, we'll look into this in a second, then you want to make sure that the quality, the cost is still what you would expect from your applications. So really important to monitor this as well. And then thirdly, the security and compliance aspect. Remember that there's an executive order out there on AI regulations from the White House. So security and compliance are now top priorities for a lot of organizations, and basically for all of the organizations that are part of this executive order. And you need monitoring tools that constantly scan your AI for vulnerabilities, keep everything in line with federal and company rules. And monitoring this is a really can be a challenge, but you want to have tools in place that actually help you get this compliance and security aspect in place. So these challenges, they call for some powerful monitoring tools that allow you to handle these complexities that the AI brings to the table and gives you actionable insights for you to make decisions based on this information. And this is actually exactly where Relic AI Monitoring comes into play. Relic AI Monitoring is the industry's first end-to-end APM solution that empowers engineers to build and run AI applications confidently with in-depth insights across the AI application stack. So it gives you insights into, optimizing the performance, the quality, and the cost aspect of your applications. Another aspect when it comes to compliance and making sure that the security and the data protection measures are in place is also something that we built into this feature from the ground up. So this is a first-class citizen when we talk about security and data protection. So what can I do to actually think about and configure my AI monitoring to the best of your capabilities? And we have various aspects. First of all, AI monitoring doesn't run by default. You can disable or enable it based on your agent installation. So you may have applications that are customer facing, that are out there, and your customers are using them, and you want to make sure that everything is safe and secure, and you can monitor all of the things, and you want to actually look at the request response scenarios from your applications to measure the quality. You can enable AI monitoring. But maybe for internal applications, internal chatbots where your employees can ask questions to HR or other systems, you may not want to put all this information out there into an observability backend. So you can actually disable this feature in this case. You can also maybe monitor the usage of your applications to still get information about the cost and the tokens being used for all of your applications, but you maybe want to disable the content. And this is also possible. This is another aspect that you can use to configure AI monitoring, where you can say, the request response scenarios, I want to disable completely. And thirdly, there's another capability that we refer to as drop filters or drop rules. So basically, whenever an agent monitors your application, monitors your different microservices and interacting with each other, they will collect the data and send it to the New Relic observability backend. And before it is actually ingested into our database, you can define certain rules where you may be looking for some regular expressions like PII data, IP addresses, whatever it is that you are concerned about. So you can provide these drop rules that will actually happen, at the ingest point of our backend, which will allow you to drop any data that you don't want to be stored permanently in your New Relic backend. Like I mentioned, this could be based on regular expressions that you can define. And these are also interestingly named or based on Grok rules, which is kind of like an industry standard. All right. So with all of this being said and setting the scene for this, I want to jump into the first demo where I actually look at a simple Python app and how we can actually configure this and monitor this and getting started with AI monitoring. So for this, I'm using a platform called Instruct, which we typically use to run these workshops. You can see I already spin this application up, so I can already get started with running this application. So Instruct, the environment that we're using here is not a New Relic product. This is a product that we use to actually showcase and spin up these sandbox environments. So you typically have on the left-hand side, just to give you some background information, you have different terminals and different tabs, different actually things where you can execute something. And then on the right-hand side, you typically have some instructions. So in this case, the first demo that I have prepared, I have a terminal here, I have an editor tab, and I have an application, which is tab, which is also basically a terminal. So what I can do is I can first of all install OpenAI. This is the OpenAI, the tool that I'm using for this demo. And then I can, once this is installed, I can, look at the version that is actually being used. And this is in this case 1.42.0. Okay, great. So now that I have OpenAI installed in the sandbox environment, I can get into the a simple Python Flask application, which I already have prepared, and which we will then use to actually get OpenAI installed, configured, and used within the application. So if I go in here, you can see this is the simple Python application. It's a Flask application that uses a couple different endpoints. For this to actually being able to run, you can see I'm referring to a OpenAI API key, which I'm exporting as an environment variable into the terminal. So if I go in here, I can actually copy this command. And then what I want to do is I want to enter my own OpenAI API key. You will see throughout this course my API key, but don't worry, I will delete all of the API keys after the session, so don't worry about any keys being misused. So this is my own API key. I have this configured now into the terminal where I'm actually running the Flask application. And this is also then the next command. I'm actually using Flask app to run the Python file in my terminal. If I then click into the other terminal and actually run this command, the echo command, this will actually expose the dedicated instance of this sandbox that I'm running on. I can then click onto this link, which will open up the UI of this simple Flask application. And this, is really simple. I tried to make it, really easy. You can tell I'm not like a UX UI designer, but it, shows the concept. I have an input where I can input some information. This information will be then sent to my OpenAI API endpoint, and I will get a response back. So let me enter a prompt here. What is LambdaConf typically known for? So let's see what OpenAI comes back with. Oops. So what is LambdaConf typically known for? Submit this, and you will get some, feedback. LambdaConf is typically known for being a conference focused on functional programming and so on. What is the typical audience for LambdaConf? You get the point. This application will simply, use whatever I input into this text box, send it to OpenAI, and then I'm outputting whatever the response is from OpenAI into this little Flask application. So this is great. I have the application up and running. And then the next step for me is actually configure New Relic AI to monitor the application, but also all of the AI interactions that we're using. So this is the next challenge. So integrating New Relic into the application is basically, follows the exact same process of getting a New Relic agent installed that will actually monitor and observe your application. What I did is I already, prepared this application so that we only have to configure the specific, license information for my New Relic account. So again, I have to use the OpenAI API key, and the information should still be in the history of my terminal. Great, I can copy paste this. Excuse me. Okay, then for each of the New Relic agents that we typically use, there's typically always a so-called license key involved. So if I click into my New Relic account, I can click into my, let me make this a little bigger. I can click into my configuration, into API keys, and this is where I will typically have my ingest license keys. I again created one specifically for this LambdaConf webinar. I can copy this key and then get into the editor, into the second level application. And what you typically have is you will have a so-called ini file. This is very specific to the programming language that you're using. But what is identical for all of the different agents is that you will only have like a name for your application and typically a license key. So these are the basic things that you need to have in place to get your agent up and running. I installed the package typically using pip in the case of Python. So I used pip install New Relic. I have then the ini file that I have available here, which I can use to configure a lot of different aspects, which we don't go into detail in here. But just to mention that I did enable New Relic AI monitoring all the way at the end of this file. You can see, machine learning enabled equals true, AI monitoring enabled equals true as well. So this allows me to actually configure, like I mentioned earlier, do I want to enable or disable AI monitoring for my application? So great. This information is saved. So I have my license key up here. So then I can go ahead and click into the next section. I can actually run my application again. In this case, the command looks a little bit different, but basically this only tells me that the Relic config file should use this ini file, which I used to enter the license key, and then I'm running the Flask application as I would before. So then if I go into the terminal again, I use the different port for this application. So now this is using port 5004. The application looks exactly the same. What is LambdaConf typically known for? I can use the same prompt. Again, submit this. Perfect. I get a response back. Maybe, some other questions that I can use. Who are you? I'm a language model. This is basically the response that I received from my OpenAI interaction. If we look at the source code just a little bit, all of this, is on a public repository. Happy to share the link as well. But basically, what happens is that I'm interacting with this prompt endpoint, which will basically send whatever I'm inputting into the chat completion message or method, which will then, make a call using OpenAI excuse me, which will use this chat interaction to actually call OpenAI. As you can see, I'm using a specific model here, GPT 3.5 Turbo. I can set some other information like the temperature, the max tokens being used. I can, specify some roles as well. I won't go into much further detail for this application. Happy for you to investigate the application in more detail. I can share the link to the repository. But basically, the application is up and running. And if I now go into my New Relic account, I can look into the section called All Entities. I can see there is an entity in the Services APM section, which is called Instruct AI Bot. This is exactly the same name that I used here in the ini file, Instruct AI Bot. So what we'll do is we'll create an entity in our platform. I can then see some high-level information across all the different things that I'm monitoring and observing. I can then click deeper into this application. So now I get like a summary of the performance, the behavior of this application. Is it working as expected? Do I see any issues? Do I have any vulnerabilities as well that some of the packages come with and so on? And then the interesting section that we are looking into for today is kind of like this AI monitoring section. So I can then look into and click deeper into the AI responses section. And this will give me like an overview of what are all the things that I interacted with. What is the chat application actually doing? In total, I had like 2 total responses. Remember, I asked 2 different questions. What is LambdaConf typically known for? And who are you as a AI engine? What is the typical response time for my application? I'm looking at the 99th percentile by default. I can change all of this, of course. What are the tokens that are being used? Did I see any errors when interacting with the AI platform and so on? And then I can look at the same type of information on a more timeline, on a more historical perspective. I can see, what are the total responses over time? What is the response time and so on? We break it down typically by different percentiles and the median. And of course, I am just looking at the last 30 minutes, but if I want to, I can also go back in time to see what was happening with my application, with my chatbot in a long period of time. And did we see any anomalies, any strange behavior and so on happening? And of course, I don't need to look at the dashboard. I can also send out alerts, send notifications via email, Slack, whatever tool you use, PagerDuty, OpsGenie. And you can, of course, also configure this to set up. What we're also seeing down here, and this is referring to the actual interaction of my chatbot with OpenAI in this case, is basically what are all the different request response scenarios that we have seen. And you can see these are the actual prompts that I used for the interaction and the actual also results that we received from OpenAI in this case. We support many different AI platforms, of course. In this case, I'm using OpenAI, but you can, imagine any other, systems of choice, like, for example, AWS Bedrock, or, some LangChain applications and so on. So I can see in this specific table here, I can see the number of completions, the number of tokens used. I can also see this specific dedicated model that was responsible for using the interaction with OpenAI. You can see, GPT 3.5 Turbo is what I configured in the source code. If I go back quickly into this and into the application, you can see I only specified GPT 3.5 Turbo and not any more specific submodel, but actually behind the scenes, this is actually what is being used. So some really nice information. And maybe, GPT 3.5 Turbo gets a new update in a month from now, and suddenly my entire behavior is different. Maybe I'm getting, different quality of responses back from my interaction. And this could be based on the actual response model that was being used. if I want to and have an interaction with the with the application. So imagine, for example, if I have some sentiment boxes here, thumbs up, thumbs down, which I could also include, which we typically see in chat applications. If I have something like this, I can also include this in my AI monitoring concept, and I can then also monitor the sentiment for the different interactions with my AI monitoring capabilities. So also really another interesting aspect, which I didn't cover in this specific session today, but this is also possible for you to monitor. So if I then jump deeper into one of these requests or responses, I can get even further details of this application. So in this case, we're looking at a single request response scenario that we use to interact with OpenAI. So this is the LambdaConf question that I asked. What is LambdaConf typically known for? And this is the response that I received from my OpenAI agent. And what we see down here is really interesting, because what we typically do is, if you make a call from your Python application and maybe make calls to external services, like, for example, OpenAI as a external endpoint, you are able actually to observe end-to-end what is happening with your application. Of course, we cannot give you further details into the OpenAI stack on that end. For us, this is basically a black box, but we see the entire chain of, from the prompt to the LLM completion, create operation, all the way to the external service. I can, observe what is happening in this kind of like waterfall view that is typically used in in distributed tracing applications. When you think of open telemetry, for example, for your tracing, this is a typical view that is typically being used. We have further information, like, for example, the metadata. What is all the different application metadata, the programming language that is being used, the model, all of the tokens. So you can see the completion tokens being used, request tokens, the total tokens actually being used. I can see the underlying host that it was used to actually run the application, the interaction to the open or to the AI monitoring vendor. In this case, you can see I'm using OpenAI, and of course, the dedicated trace ID and conversation ID if it is applicable. But we don't stop here as well, but we give you even further information about your interaction. So in this case, I can see, for each of the different spans, so the different sections of a single interaction are typically called a span. I can get further information about each and every parts of this trace, so that you can understand what is actually happening. So you can see, if I'm looking at this specific trace, I can actually see all of the different messages. Excuse me. So the entire history of what was used in the interaction. In this case, this is only just a single request response scenario. But imagine, like, even in ChatGPT, you have this whole history of, hey, I wasn't happy with the response. Can you rephrase this a little bit? Can you add some additional information? Can you maybe change the tone of your response? All of this is then shown in the completion messages here, and you can monitor this as well. So this is important information to monitor what is happening with your application. Of course, we show you even further details. If you want to, you can disable or unselect this box, only show AI spans, and this will then give you the entire trace all the way from the front end, the web interaction, all the way to the back end, and all the different insights into your application. But this is not the topic for today. Today, we want to focus on AI monitoring. And this is some nice information where I can only look at dedicated AI monitoring capabilities and spans that are reflected in this capability. Okay. This is this is great already, right? So I can, easily spin up the agent. I can configure it to monitor my application behavior. But what is next? What else can we do? I have also prepared a section on, if you're not familiar with New Relic, on how you can explore New Relic and look at all the different things that we provide here from an APM, distributed tracing, front end, real user monitoring perspective. And I also added some screenshots in here to show the same things that I just showed you on the screen. So great. This was basically the first section, the simple Python app that I used for the first demo. So now let's jump into a more advanced use case, because a simple simple Python app that just makes a call to OpenAI isn't really a real world scenario that we typically see out there. So in the next demo, I'm using, just for the sake of it, a different language. So I'm using Node.js application that leverages OpenAI as well, but this time with a Pinecone vector database, which is used as a so-called embedding. So what is actually happening here is this Node application, which is also kind of like a simple chat service that we're looking at. This will actually interact with a OpenAI embedding model, which will then refer to Pinecone as the underlying vector database. So I already configured Pinecone. We will I can show you the Pinecone index in a second. But basically, the embedding model will then talk to Pinecone. It will know that for some specific requests, it has some references to some games that I have provided here in Pinecone. And then I can request some different games. I can select different games that I want to play using OpenAI as a chat interaction engine. I have pre-built already some prompts for all the different games that we're using here. So whenever you select a game, then from the Pinecone information that stores this type of data, I can then use that prompt that is prepared, send this to the OpenAI chat completion engine, and then I get a response back. We will look into this in a second. This response is then sent back to my chat service, and then I can interact with OpenAI and actually play, in quotation marks, play the game using OpenAI as a request response scenario in this section. So this is a much more advanced use case. It kind of like reflects what is typically out there. So many companies already run these applications with some additional information that is stored in vector databases. You may have heard about the term called RAG, which is typically being used as augmentation engines to actually add additional capabilities or add additional features. We all know that maybe AI applications are not really dedicatedly or specifically good at math. So typically what happens is that you could use an embedding that actually gets triggered whenever a user wants to do some math calculations. So whenever calculus is being used, then don't send the request directly to OpenAI. We will use our function, for example, that actually is responsible for doing calculations, and then send the data further into OpenAI to basically come back with a natural, response in real language that actually, tells you then, hey, the math calculation that you wanted to execute, this is the response that is that we came up with. So in this case, I can use some more, dedicated systems that actually are responsible for certain tasks. And in this case, the dedicated system that I'm using is a Pinecone vector database where I stored some different games. Ideally, this entire process, this entire flow of my interaction is also something I can easily monitor using agents to understand what is happening, including all the different embeddings that are being used. And ideally, I have the entire process as part of one single interaction or one single trace in New Relic as my observability tool of choice. And I can then dive deeper into the different aspects. Where was maybe my interaction slow? Was it OpenAI or was it Pinecone request? Do we see any anomalies? Is some service basically maybe falling off the rails? So a lot of different things can happen in a real world application. And ideally, you have a lot of information available at your fingertips so that you know about all these things and can actually act accordingly. So, and this is basically the next section that we're focusing on. So this is the advanced AI observability with New Relic section. Again, I have prepared a different application. As I mentioned before, this is a node application that I'm using here. And again, you'll see in this challenge, we have this application. It uses Pinecone, OpenAI, as I explained before. And what I need to do in order to get this up and running is basically similar to the steps that I used before. I need to prepare my OpenAI API key. And just for the sake of it, I already, prepared this in here. I can use this to enter my OpenAI API key. And then since I have pre-built already a Pinecone vector database, I'm using also a Pinecone, some Pinecone credentials here, where I'm defining what is the namespace that I'm using, where's my Pinecone residing, and so on. And just to give you some insights, this is the Pinecone environment that I'm pre-built already. I have one index as part of my Pinecone environment. If I click into this specific index, you can see the different underlying infrastructure. It runs on AWS and US East 1. It is running as a serverless index and so on. And then you can see as part of this vector database, I have a couple, items in here. I have basically all the different games that I want the users to be able to play in here as different matches. So I have a chess game that I can play. I have a game called 20 Questions. I have other games like, for example, Higher and Lower, which I'll be using in this specific section. Noughts and Crosses, Chess, Othello, and others. So there's a couple different games that I have prepared here. And you may also know that or notice that there is a prompt as part of this interaction, and also a description that I've used here. So we'll see how this looks like in a second. So I have prepared my OpenAI API key. I have prepared my Pinecone environment. The last thing that I want to do is, again, use my New Relic license key as part of this. Like I mentioned, I used, this is a Node.js application. We can quickly look into the source code of this. So you will notice there's a package JSON that I'm using here to install different kinds of dependencies. And one of the core dependencies is, of course, OpenAI, which I'm using here. And then if I look into the routes, this is basically just a API backend application. It doesn't have a front end attached to it, but basically it has different routes for activities, for the games. I can search my vector database based on maybe some games that I want to play. And then I can interact using the chat interaction with OpenAI. But what I'm doing here is kind of like I'm using the embeddings of the capabilities in here to actually initialize the vector database as an embedding for my OpenAI interaction. All right. So if I want to get this up and running, excuse me, I can, click into the chat service and do the typical commands, npm install to install all the different packages for Node, and then I can use npm start to spin up the application. So this is up and running. It is using port 8081 for now. I could go and get the dedicated instance ID of my sandbox. But if I then access this application, this will come back with like a 404, not found, because like I mentioned earlier, this application basically just uses API endpoints to serve a couple different endpoints. All right, but what I built also is kind of like this UI. Again, this is using a Python Flask application. I can quickly install this and get this up and running. Here you go. This is running on port 5004 again. And then I also have the user interface as part of this instruct course available here in a different tab. So what I can do now is first of all, I can request, give me all the games that I am able to play using my interaction here. So I can click on this Get Games button. You can see my really nice, UI that I built for this specific demo. In this case, for the sake of it, I'm using higher or lower as a game that I want to play. I can input this into this next prompt. I can then retrieve the prompt that I will be using to actually interact with OpenAI in this case. So this is the prompt that I have prepared. Quickly reading this, you are an AI who likes to play higher or lower. Pick a random number from 1 to 100 and remember it. Ask the player to try to guess the number. Respond back if the number that the player guessed is higher, lower, or a match for the number that was originally picked and remembered. So this is the actual prompt that I will be using to actually interact now with my OpenAI environment. I can click on Submit Prompt. This will then initiate a chat ID so that I can track all the history of all my interactions. And then the response from my OpenAI application is, I have picked a random number from 1 to 100. Please try to guess the number. Let me know your guess, and I will tell you if it's higher, lower, or a match. Let's start playing higher or lower. Okay, great. So I can then, get into the next text box here. I can, start, since it's between 1 and 100, I start with 50. And I can do some divide and conquer. So now that I entered this, ChatGPT came back with, or OpenAI came back with a result. So the number I picked is lower than 50. Try guessing again. Okay, I can then, guess again, 25 maybe. Okay, now the number is higher. So again, divide and conquer, 33 is lower than 33. Just let me finish this so that you know what is actually happening. So now it's higher than 28, so maybe 31. Congratulations, you guessed the correct number, which was 31. Well played. Do you want to play again or try a different game? So you get the point. I was able to ask, my AI chatbot a question on, what games am I able to play? I then picked a game and then, used the prompt that was actually referred to from my Pinecone database as a prompt to my AI, platform of choice. And then I could get back a response and actually was able to play the game in a, interactive fashion. Okay, great. So how does the result look like if we jump into New Relic again and look at the result of this interaction? Again, I can click into all entities just to show you the name that I picked for my application. So in this case, again, this is Node.js, so I'm using a newrelic.js file. It's very specific to the Node.js environment. But again, what I'm using here is a APM name or an app name, and this is exactly what shows up here. So the chat service node application, this is the node application interacting with an embedding for Pinecone and OpenAI. you can see I already see some performance results. This is the summary page of my New Relic APM application. I can see the throughput and so on, some interesting aspects automatically by not changing anything within the application, but just using an agent that I attach to the application at startup time. Again, I'm not going into further details of what the APM experience looks like. I want to dive deeper into the AI responses section again. So in this case, I'm using, I can see the total responses. I've seen 6 requests. The average response time was this. The tokens being used in average were those. And then I can also see the entire interaction here as I have played the game. You can see, this is the initial prompt that I used, and then all the different interactions that I used while playing the game. And finally, guessing the correct number for the higher or lower game that I used for this demonstration. Again, I can click into the details of this specific interaction. I can see the input and the response. Again, some metadata if I want to. And then if we look down deeper into this section, you can see there's also some additional information that we see, including all the chat completions and the interactions. Excuse me. And if I maybe click into one of the interactions that we see here, I can also see what is for example, the DNS connection and so on for my application being used and so on. So great. This is great information. And what I wanted to show as well is that we also have all the information around logs, for example, at your fingertips as well. So whatever the application spits out as in the console as a standard out, or for your dedicated log monitoring framework like FluentBit or the typical frameworks that you use, this is all available also as well here for you to analyze what is going on, what is happening with your responses. You may have noticed as well, there's also a section called Model Inventory. And if I click into this, you can also see the different models that were being used. I can see an overview across my request response scenarios. I can see the average response time, the average tokens being used, and so on. If I had any errors, I could also dive deeper into those. I can look at performance and also cost. Cost not in dollars, but in tokens being used. So actually, you have seen before in the metadata of each of the spans of all the requests, we were able to identify the input and output tokens being used when we interacted with OpenAI in this case. So I can also dive deeper into this section. Okay, great. What's next? Basically, when we think about AI applications, we will typically use not only one model, but maybe I, as an organization, I want to play around with different models. I want to see whether maybe ChatGPT or GPT 4.0 or 4.0 is maybe giving me better results or maybe faster results for my interactions. And also, you will notice that for each of the different models, like in this case, GPT 4.0 has a dedicated price point attached to the input tokens and also the output tokens. So in this case, for GPT 4.0, this is the default pricing. I don't have any custom pricing models, but basically for the default pricing, it is $5 per 1 million input tokens and $15 per 1 million output tokens. If I then look at, for example, other models, for example, GPT 3.45 Turbo, which I used right now, it has completely different pricing attached to it, right? The input and output tokens, they have completely different price points. And again, so how do I find out on what is the best model? What is the best, cost per quality aspect maybe, or cost per performance for the different models? And this is also an aspect that we want to cover using AI monitoring, where we will try to give you information about all the insights about the different models being used and maybe the submodels behind the scenes that OpenAI maybe puts out into the for you to play around with. So in this last demo, what I wanted to show is kind of like looking at different models. So what we will do is we will look at 3 different models. I will run the same exact same application. In the first instance, we use GPT 3.45 Turbo. In the next section, we will use GPT-4 Turbo and GPT-4o finally. And then what we try to achieve with this is kind of like getting an overview across what is the model, the underlying model that gives me the best performance ratio. What is the model that provides me with the best, costing ratio for input and output models based on my specific scenario that I'm using for my application. It may be completely different based on the underlying model that I'm using. So in order to, maybe you can try guessing what is actually happening. I prepared a poll for this. I'm not sure if this is working here. Maybe it isn't possible here in this webinar, Zoom webinar. But basically, if I look at the chat, is there any, information on what do you think? What is your gut feeling of what is the best model to use when it comes to performance and when it comes to tokens being consumed? Any guesses out there? I maybe wait here a minute or two and see what the results are. Okay, I also see a question in here regarding the level of accuracy of the responses given. So I mentioned it at the beginning that you typically would have some kind of feedback or sentiment being part of your AI or chatbot application that you put out there. So in general, end users of your chat application, they can, provide you a thumbs up, thumbs down. And based on this and, measuring this across all your entire request response scenarios, you can then, get information on is the sentiment, is it better or worth using different models, right? Can I, based on the different timing or based on the quality of the responses, I can then measure all of the sentiment and make decisions based on this. So Virgilio is saying that, the GPT-4 Turbo is the one with the slowest response time, if I'm guessing. Maybe you can. So what I was looking for is kind of like which of those models has the slowest average response time, and which one is the one that is basically the one that is using the most or the least amount of tokens being used. So you are guessing GPT-4 Turbo is the one with the slowest response time. Sorry, I'm sorry that the poll that I prepared is not working. For O the slowest, oops, I'm sorry. For O the slowest, so let me just put this out there, and then I guess for 3.5 Turbo, oops, is the one that is kind of like in the middle. Any guesses on when it comes to tokens consumed? Which one do you think uses the most tokens? 3.5 Turbo, 4 Turbo, or 4.0? Any guesses?
Oh, Harry, I think I can actually prepare that poll. Just give me 1 second.
Okay. Oh, that would be even better. I mean, we also don't need to waste time here, being a little sensitive of time.
No, it's okay. This is almost done. Let me see if it comes up for you.
Okay. Um,
Does it show up?
should it show up in the Zoom panel?
Mm, let me see. Okay, it seems like it's saving now. Let's see.
Okay.
Okay, and launch. Okay, it should
Ah,
show up now.
perfect.
Wonderful. Thank you.
Thank you. I should have shared this earlier. So maybe we'll wait for another minute so that people can, put in their choices. It's always interesting to see, to the results at the end, because this is not information that you typically are easily able to capture, right? I mean, you could capture this and maybe save them somewhere else or put them into logs or capturing them this way, but ideally, with using AI monitoring like that we provide you with New Relic, this is really easy to capture all the details and all the information. So just to repeat, the first section is responsible or targeting the performance aspect of your different models, and the second one is of course most tokens being consumed gives you a direct impact on the cost for running your AI application with your AI platform of choice. In my case, this is OpenAI, but basically all the different vendors have their own, charging pricing models. Or if you run your own LLM applications, maybe you have to think more about the underlying infrastructure, which is also an important aspect. Based on the infrastructure that you provide, does it give you fast enough response? Do you see any changes in behavior and so on? So again, even if you run your own LLM application and there's interesting, frameworks and tools in place like Llama Edge and so on, but basically, the performance and cost are typically two different aspects that are, important to measure. Should we close the poll, Christina, or?
Oh, yeah, sure. It seems like GPT 3.5 Turbo is the winner.
Okay, so most tokens consumed. Okay, so let
Gotcha.
me quickly just put this in here with my nice smileys here, and I assume. Okay, and then for turbo and then for O. Okay. Oops. So oops. All right, and then I guess your guess is that GPT-4o uses the least amount of tokens and so on. So let's go ahead and find out about it. So I can already skip all of this section, click to the next step. And then what happens in the next section of this demo, we actually use GPT-4 Turbo as the next model to run the application. As I mentioned earlier, if I click into the source code, what we used here is GPT 3.5 Turbo. I actually already prepared different branches for this so that I don't need to change any source code live, which is already always a challenge. So let me again pull up my environment variables to use and actually run the application. While the chat service is spinning up, let me also spin up the UI So this should be up and running. We are now using GPT-4 Turbo. I switched to a different branch. And now I can, again, run the same type of interaction that I used earlier. Just for the sake of comparison, I will use the same game. I will submit this prompt. And then I will try to interact with the game as fast as possible so that we are able to get a response. What you'll notice is you will notice a different, the prompt is exactly the same as before, but you will notice a different response here from the chat interaction. And this is based on the model being used, right? I'm using a different model, so it has completely different behavior. Again, I'm guessing 50 as a starting point. Okay, the number I picked is lower. Also, these responses are slightly different to what we have seen earlier. So the number I picked is lower than 50. Okay, great. Let's use 25. Is higher. Okay. 33. Higher. Okay. 45. 38. This is probably so exciting watching me playing this game. Okay, 36. What did I do? 34. Congratulations. You guessed the number correctly, and so on. Great. So without further ado, I will again skip to the next section. I will skip all of this. So we have, used GPT-4 Turbo now as our model. I will skip to the next section. All of the responses are being captured and sent to the Relic already. So in this case, I'm using GPT-4o as my model. So I'm switching to this different branch that I prepared. Let's verify that this is actually using the model. Yes. So I switched to the 4o model that we'll use now. I need to prepare my environment variables again. Excuse me. All right. I can now, again, spin up the chat API backend application. I can spin up the UI as well. Great. This should be up and running. The chat application is also up and running. So again, I'm using the exact same interaction. I will use higher or lower again with the 4o model now. Again, the prompt is exactly the same. This comes from my Pinecone interaction. I can submit the prompt. Again, the response will be slightly different based on the new model that we're using. I can pick my first guess, 50. Your guess is 50. Let's see. The number I picked is higher than 50. Okay. 75. The number I picked is lower. Okay. 63. Higher. 71. Congratulations. You guessed it. The number I picked was indeed 69. Great. So now that we used various kinds of models, I can then jump again into my chat service. Again, from the overarching performance of my application, I can see the overarching, performance from my web transaction time, breaking it down into internal Node.js time that is spent and also external time. But what we actually want to look at is actually the AI responses. So in this case, I can see the overall total responses, and let me expand this into a broader time window. So I can see, 21 total responses. This was the overall response time from the 99th percentile, the number of total tokens used per response. This is the average. This is also the 99th percentile. I could look at the average, for example, if I want to. And then again, I can see all the request response scenarios down here. But what we also see is the different models being used. So now I can see the same interaction, but also looking at different models that we see here. So now GPT-4 Turbo, for example, I have a completely different section in here. And so what you see here, and this is what I wanted to show earlier as well already, is I can also see the entire interaction all the way from the post request that I have identified or that I'm sending from my simple UI all the way down to the actual create command to OpenAI, which will then interact with embeddings and so on. So the entire AI chain of interaction is what I'm being able to observe here. But what we actually wanted to focus on is kind of like getting a model inventory. And this is what this section is now able to bring me really detailed information about the overview of all the different models that I've used. I can see the total request responses, and this may not be like 100% accurate because, I maybe for GPT-4 Turbo, I had to use more guesses to use or to guess the correct number that was being picked. But from an overall perspective, I can see the average response time all the way from top to bottom is basically, I can see GPT-4 Turbo was the slowest in responding to my requests in average. I can see 4.0 being the middle and 3.5 Turbo being the fastest when it just comes to using the average response time of interacting with my AI application. I can also see the average tokens being used. So in this case, for GPT-4 Turbo, 294 tokens, GPT-4o, 264, and 242 for GPT 3.5 Turbo. But the question is, does this give me the whole picture, right? Probably not, because I also want to maybe look at the quality of the responses and maybe look at the sentiment. Did I receive great feedback when switching to different models from my end users? Is the sentiment going up or down? I can monitor all of this on a historical timeline and actually make then decisions based on this information for my future plans to roll out other models. I can see also the same type of information on a timeline. What request response scenarios did we see over time? Of course, I used the different models in a one after another, but maybe you're playing around with different canary releases on running different models in parallel, and then you can directly compare the results, the tokens, the cost, the performance, all of this at the same time. You don't need to run this after another, right? You can run these experiments in parallel to make decisions on what is the best cost per performance or cost per quality ratio that I want to achieve for my AI chat application that I want to put out there. And also, this then gives me information about, also the different, duration for each and the tokens being used for each of the interactions that we have seen. So maybe I want to optimize my model. Maybe I want to optimize and maybe let the users create more specific or dedicated prompts for my application. If I see for some request response scenarios that I'm seeing a huge number of tokens being used, maybe I can optimize my application and performance and fine-tune it to actually use less tokens but giving the same type of quality. This is then really something that gets into the details of my AI monitoring pieces. We are not covering all of the details in this webinar, but it just should give you some information and some indication of, what are all the things that I need to keep in mind and need to look at when it comes to AI application monitoring and looking at the various details. The last aspect that I wanted to show you is I mentioned the pricing. Again, I'm using OpenAI in this demonstration, and we have seen the different pricing tokens here before. What the standard AI monitoring concept brings you is giving you details around all the tokens being used, like the input and output tokens, and I can track them over time. But what it does not give you is the actual cost in dollars that are being consumed, because you may have different prices, being discussed with OpenAI, and maybe you have different, price points attached to your models. What's nice about New Relic is also that you can prepare what we refer to as lookup tables. If I'm getting into the logs section of my New Relic account, what I did here is I actually entered in the different price points for the different models into New Relic as a so-called lookup table. And what this allows me is then I can then use this lookup table to actually, bring up a custom dashboard, which I have prepared here. So in this case, what I'm entered into the lookup table is basically this information here, where I entered in for different models, and you can get all the details for the different models from the pricing page or from your contract that you have with OpenAI. So I entered in for 3.5 turbo. These are the price points per 1 million tokens, input and output being used. GPT-4o has a different price point, and so on and so forth. So once I have the actual price point attached to it, I can then use custom dashboards where I have access to all the raw data that we collect. And I can then, put all of this information into a dashboard like this, where I can then actually, get back with what are the total cost in dollars based on the different models that I used. So for example, for all the different requests and responses that we have used and the input outputs tokens attached, I can see that for GPT 3.5 Turbo, this is by far the cheapest because it has a different price point for the different, input and output tokens. So GPT-4o, gives me even a slightly worse, costing aspect, and GPT-4 Turbo again. So I can use this information to directly attach cost to all of the different aspects. I can then break it down by input and output cost. If you want to look at and are curious about the underlying query, what New Relic uses is its own query language, which is called NRQL. It is similar to SQL. New Relic query language is the actual name of it. So you can see I'm using this lookup table where I actually stored the actual cost that I have to pay OpenAI for all the interaction. And then I can map it against the actual input and output tokens being used in my applications. I can then facet, which is basically in SQL, which is a group by in SQL. I can then, put this out there and actually, calculate then the actual cost in dollars or in any other currency that you're using. But basically, this then allows me to look at, maybe the input and output tokens are not that interesting when it comes to, observing all of this, but the actual dollars, they do give me some much more details into what is actually happening. And then, of course, I can, graph this information over time and then like time series database or time series widget and look at all of the interactions. If I want to, I also have access to all the raw data. I could analyze this. I can export this, do whatever I want to do with that type of data. But I have all the possibilities from here on because we capture a lot of details when it comes to AI monitoring. Okay, this and then we can compare this, with the guesses that we had earlier. GPT-4o being the slowest response time, GPT-4 Turbo the fastest, and so on. We can actually compare this then with the actual results from our interaction. Let's quickly do this. And then I can bring up the inventory, and we can definitely see, what is actually the slowest is for Turbo 3.5 and 4.0, which is probably, slightly different to what we guessed at the beginning. But, having these actual facts in place and can, monitor them, this is really the benefit of using AI monitoring with your applications. This also already brings me to the end of this webinar and the end of the presentations and demos. Let me have a look into the chat whether there's any questions. Virgil, you had a question. Could there be a business case for companies to store AI responses along with their corresponding queries and then use these stories? So yes, so ideally, this could be used maybe, if you think about, maybe some internal customer knowledge bases, for example, where you have frequently asked questions. Think of like an internal chatbot for large enterprises where people can ask questions, maybe use it as a knowledge base. So yes, you could use this and export the data. New Relic allows you to actually export all the data that we capture. You could use this then maybe, into your own, knowledge base, or, use it to actually generate a frequently asked questions document with some good responses. You can, fine tune and tweak the responses then in the FAQ document. But yes, this is definitely possible and could be one of the use cases. Not sure if I answered the question. Okay, great. Excellent. Christina, did I miss any questions? I'm just browsing through the chat here.
I don't think so. Actually, I think one of them you actually must have mind read and responded without even noticing. So I think you hit them all.
Okay, perfect. Are there any other final questions? I guess we have 2 or 3 minutes left for the webinar. So maybe one aspect, the Relic allows you to sign up for a completely free account. We don't charge anything. You can use that forever. We have the only restriction is you have like 100 gigabyte, which is a lot in my opinion, 100 gigabyte per month free of data ingest. And data ingest could be anything. That could come from application performance monitoring, AI monitoring, infrastructure, whatever you are interested in. So this is a nice way to play around with this if you want to, use this in your own AI application and want to see, what result and response did we, provide you with our AI monitoring capabilities. And of course, as with the AI, vendors like OpenAI and others, they are constantly evolving their AI models and coming up with new models. And of course, we are also constantly evolving our AI monitoring capabilities. What we have seen today is, as of today, what we offer you. We are looking in, getting feedback. If you use your free New Relic account to play around with it and have, run into any issues, have any questions, any enhancement ideas, feedback, you can always get in touch with me. You will probably find me on all the social medias if you search for Harry Kimpel or at Harry Kimpel on all the various social media platforms, Twitter or X, how it's called to these days, Blue Sky, Mastodon. You will probably find me. I'm happy to always answer any questions you may have. Thank you for your time. I hope this was interesting, and I hope you, got some first impression of what AI monitoring could look like as of today. it may change in the future, but yeah, I hope this was interesting and provided some interesting insights.
For sure. Thank you so much, Harry, for taking the time. That was wonderful.
Thank you for having me.
Of course. Well, if anyone else wants to find you, yeah, Harry Kimpel on social media. And if you have any questions, if you're watching on YouTube, feel free to leave a comment and we'll make sure to ask Harry about those. Thank you, everybody, and have a great rest of your day. Bye.
You.
And so, our quest comes to an end, with knowledge gained and bonds forged fast. The unicorn's light shall guide you home, as the legends of LambdaConf become your past. But fear not, brave heroes, for your journey continues, with new challenges to face and skills to hone. Until next time, when the unicorn calls, and the legends of LambdaConf beckon you home. For in this realm of code and wonder, your legend shall forever be sung.